The James Webb Space Telescope, JWST, is pretty much the best telescope we've got for space research. It's all about figuring out our solar system, those far-off planets around other stars, and the crazy structures that make up the universe. Recently, some scientists pointed the JWST at a star 120 light-years away, and guess what they found? Some stuff that suggests there might be carbon-based molecules in the air of a planet that could have oceans. That's wild. It's like finding a planet super different from anything we have here, and it makes you wonder if there are other livable planets out there. Want to know more about this exoplanet? Keep watching, and if you want to stay in the loop about the universe and all that, hit subscribe, like this video, share it, and ring that notification bell. So, NASA's James Webb Space Telescope found something big about an exoplanet called K2-18b. It's about 8.6 times bigger than Earth. What's so cool is that they spotted carbon stuff like methane and carbon dioxide in its atmosphere. This makes it even more likely that K2-18b could be a place where life might be able to survive. It looks like it has a lot of hydrogen in the air and oceans on the surface. The Hubble Space Telescope took the first look at this exoplanet's atmosphere, which helped us understand it a lot better. K2-18b is way out there too, 20 light-years away in the Leo constellation. It orbits around a dwarf star called K2-18, which is in the habitable zone of its system. Exoplanets like K2-18b are weird because they're between the size of Earth and Neptune, and we don't have anything like that around here. The fact that K2-18b might have a bunch of carbon and a hydrogen atmosphere is super interesting to scientists. A lot of them think these planets could be the perfect place to look for life. The methane and carbon dioxide, along with the lack of ammonia, suggest there might be an ocean under that hydrogen air. Some early studies even hinted that there might be dimethyl sulfide in the air, which is something life on Earth makes. Marine plankton makes most of it here, but it's not a sure thing yet. We need to check if the amount of dimethyl sulfide is actually there with the JWST. A scientist from Cambridge said that even though K2-18b is in the habitable zone and has carbon stuff, it doesn't mean there's life. It's also pretty big, like 2.6 times bigger than Earth, so its core could be surrounded by a thick icy layer, kind of like Neptune. Plus, the hydrogen air is thin, and the surface is water. Even if there are oceans, they might not be good enough for life to survive. But hey, researchers got the most detailed look at a habitable sub-Neptune planet so far, and they pinpointed what molecules are in its air. Someone from Cardiff University said they figured this out by looking at light from K2-18b's star as it passed through the planet's atmosphere. K2-18b is a transiting exoplanet, which means it dims a bit when it passes in front of its star. That's how NASA's K2 mission saw it in the first place. While it's passing in front of its star, some light shines through the exoplanet's atmosphere. Telescopes like the JWST can pick up on these signals and figure out what gases are there. The research team is planning more tests with the JWST to make sure of what they found and learn more about the climate on K2-18b. Their big goal is to find signs of life on habitable exoplanets that would change everything about how we see the universe. Oh, and the JWST found some other awesome things too. Astronomers using the telescope have spotted complex organic molecules that look like smog or smoke way out in a distant galaxy. This is the earliest we've ever seen stuff like that in the universe. Honestly, I think it's amazing and a little scary because these discoveries from way out there are changing how we think about the universe. The cool part is that these molecules, called aromatic hydrocarbons, were in a galaxy that formed when the universe was only about 10% of its age. These carbon molecules are in petroleum and coal here and in smog, and they're really big and complex with tons of atoms. What's crazy is that they formed so soon after the Big Bang, which is not what we thought would happen. To put it in context, the light we saw from that galaxy started its trip less than 1.5 billion years after the Big Bang. The universe is around 13.8 billion years old now, so we are basically watching the universe take its first steps. It's super impressive that the Webb telescope made it possible and will keep letting us see things like that for almost another billion years. If we could look even further back, would we see even more of these molecules, maybe closer to the Big Bang? That makes you think about what we know about the universe. Before, we could only say that those molecules were there, but now, with the Webb's super high resolution, we can see exactly where they are located. Also, the molecules aren't spread out evenly in that early galaxy, which is still a mystery. What's also incredible is that this galaxy was already as big as ours, with stars that had made as much carbon and oxygen as the Milky Way, even though it was only 1/10 the age of our galaxy. As we go deeper into space with all this knowledge, it's pretty humbling to see how massive and complicated everything is. With every discovery, we get a little closer to figuring out the secrets of the stars. As our space exploration carries on, it's just a matter of time before the universe tells us even more. Tell me what you think in the comments section. If you like the video, please subscribe and turn on the notification bell as we learn more about the universe. The James Webb Space Telescope keeps giving us these awesome insights. It's changing how we look at exoplanets and other stuff out there, pushing the limits of what we know about space. This amazing telescope lets us see further than ever before, uncovering mysteries that scientists have been trying to solve for ages. Finding complex organic molecules in those distant galaxies is just one example of how the JWST is changing how we see the early universe and the way it has changed over time. One of the coolest things about all of this is that life, or at least the ingredients for life, might be out there in places we never thought possible. Finding those carbon compounds in the atmospheres of exoplanets like K2-18b opens up new ways to study possible signs of life on planets that might be a little like Earth. These compounds, including methane and carbon dioxide, are often linked to life processes here. But just because they're there doesn't mean there's life. It just means we need to dig deeper and see what else is going on out there. NASA is planning on doing more exoplanet research with this potential in mind. The Webb telescope is able to analyze the air around these exoplanets with crazy accuracy, which is a big step forward. Scientists can find not just the basic stuff but also complex molecules that might hint at life. This is key to understanding if those distant planets could be lived on. As we learn more, we have a better chance of spotting small signs of life, like weird gases in the air, organic molecules, and other clues. Besides hunting for exoplanets, the JWST is also helping us figure out how galaxies form and change. By looking at those distant galaxies, we can trace the history of how stars formed, how elements are spread out, and what makes galaxies grow. This is super important for understanding where our own galaxy, the Milky Way, came from and how it has changed over time. The fact that we found aromatic hydrocarbons in a galaxy that formed so early means we are learning a lot about the early universe. As we keep exploring, every new discovery brings us closer to answering some huge questions. Are we alone? What does it take for life to thrive? How did the universe come to be? And what's next? The James Webb Space Telescope is giving us the tools to tackle these questions, offering a peek into the farthest reaches of space and time. In the next few years, we can expect even more crazy discoveries from the JWST. It can study the early universe, exoplanets, and the things that make the cosmos work. Its observations are sure to lead to new insights that will challenge what we think we know. The possibility of finding new planets, studying their atmospheres, and spotting life beyond Earth is more likely than ever. Every time we look, we're reminded of how much there is still to learn. The Webb telescope, with all its power, is leading the way in our quest. It's not just a tool for astronomers. It's a sign of how curious humans are and how driven we are to understand the cosmos. As we look ahead, we can be sure that the discoveries made by the JWST will keep amazing and changing how we see the universe, helping us tackle questions that have been bugging us for centuries. As the telescope keeps scanning the skies, who knows what incredible things we'll find. Whether it's finding new exoplanets, checking out distant galaxies, or spotting life in unexpected places, the James Webb Space Telescope is leading the charge in space exploration. Its mission is all about discovery, one that will shape the future of astronomy and how we see the universe forever. The James Webb Space Telescope is not just about making new discoveries. It's about fundamentally changing how we look at the cosmos. With its groundbreaking technology and unparalleled sensitivity, JWST is reshaping the very foundations of modern astronomy. While telescopes like Hubble have made incredible contributions, the JWST takes things to a whole new level. It's designed to peer deeper into space, closer to the beginning of time, and to analyze distant objects with far more clarity and precision. One of the most exciting aspects of JWST is its ability to observe in the infrared spectrum. This means that it can see objects and phenomena that are obscured by dust or gas in visible light. This is especially important for studying distant galaxies, the formation of stars, and the birthplaces of planets. By capturing infrared light, the JWST can reveal information that was previously out of reach, opening up whole new realms of knowledge. Its advanced mirrors, which are much larger than Hubble's, allow it to gather more light, making it possible to see farther and more clearly than ever before. One of the telescope's primary missions is to explore the formation of the first galaxies in the universe. When the universe began with the Big Bang, it was a hot, dense, and chaotic place. As it expanded, the first stars and galaxies began to form. However, these events occurred billions of years ago, and much of the light from those early galaxies has shifted into the infrared spectrum due to the expansion of the universe. The JWST, with its ability to detect this infrared light, is perfectly suited to explore these ancient structures. By studying these early galaxies, scientists hope to learn more about the conditions that led to the formation of stars, galaxies, and the complex structures we see today. Not only is this important for understanding the evolution of the universe, but it also offers a glimpse into the very building blocks of existence. What were the first elements that formed? How did the first stars ignite? These questions are at the forefront of cosmic exploration, and the JWST is the tool that can help answer them. Beyond the distant past, the JWST is also a game-changer in the study of exoplanets. As we continue to discover more planets around other stars, the question of whether any of these planets could support life becomes increasingly pressing. The JWST's ability to study exoplanet atmospheres in detail could be the key to answering this question. By analyzing the light that passes through an exoplanet's atmosphere, scientists can detect the presence of gases that might suggest the planet is habitable or even home to life. For instance, the detection of water vapor, methane, carbon dioxide, and other organic molecules in an exoplanet's atmosphere could indicate the potential for life. These molecules are often associated with biological processes on Earth, but their presence doesn't automatically mean life exists. Instead, they provide a crucial starting point for scientists to investigate further. With the JWST, astronomers can now study these distant worlds with unprecedented accuracy, honing in on the details that could reveal the secrets of alien life. The search for life beyond Earth is a complex and multifaceted endeavor. While the discovery of specific molecules like methane or oxygen in an exoplanet's atmosphere would be exciting, scientists are also looking for patterns that might point to biological activity. This includes things like seasonal variations in atmospheric gases, unusual chemical reactions, or unexpected fluctuations in the planet's light signature. The JWST's sensitivity to these kinds of changes could help detect signs of life in the most unlikely places. The ongoing search for life is not just about finding living organisms. It's about understanding the conditions under which life can arise. The discovery of a potentially habitable exoplanet like K2-18b is a critical piece of the puzzle. Planets that are located in the so-called habitable zone of their star, where temperatures are just right for liquid water to exist, are prime candidates for life. The JWST's ability to study the atmospheres of such planets gives us a unique window into their potential habitability. One of the most remarkable features of the JWST is its ability to study not only planets within our own galaxy but also objects and phenomena in galaxies far beyond. By observing galaxies that formed when the universe was still very young, the telescope is helping astronomers piece together the history of cosmic evolution. These distant galaxies, seen as they were billions of years ago, offer a snapshot of the early universe. Studying their formation and growth can shed light on the processes that shaped our own galaxy, the Milky Way. The data gathered by JWST will also be instrumental in improving our understanding of the life cycle of galaxies. Galaxies are constantly evolving, and by observing different stages of their evolution, scientists can better understand how stars are born, how they die, and how they shape the environments around them. This knowledge is crucial for understanding not just the history of galaxies, but also their future. The information gathered by the JWST will help astronomers predict the long-term behavior of galaxies and gain insights into phenomena like galaxy mergers, star formation rates, and the distribution of dark matter. Another important aspect of JWST's mission is the study of star formation. Stars are the fundamental building blocks of galaxies, and understanding how they form is key to understanding the broader structure of the universe. By observing the earliest stages of star formation, the JWST can help scientists investigate how stars gather mass, ignite nuclear fusion, and evolve over time. This knowledge has profound implications for understanding the origins of the elements in the periodic table, as stars are responsible for synthesizing most of the elements we encounter on Earth. While most of the excitement around JWST's discoveries revolves around the distant universe, its potential for studying objects closer to home is also significant. For example, the telescope is equipped to study planets, moons, and asteroids within our own solar system. It can analyze their atmospheres, surface features, and composition, providing new insights into their formation and evolution. This is particularly valuable for understanding the origins of our solar system and the potential for life on some of our neighboring worlds, like Mars or Europa. JWST is also an essential tool for understanding the cosmic web, the vast interconnected structure that makes up the universe. This web consists of clusters of galaxies, individual galaxies, and the dark matter that binds them together. By studying this web in more detail, the JWST can provide crucial clues about the distribution of matter across the universe, the role of dark energy, and the ultimate fate of the cosmos. One of the most profound implications of the JWST's discoveries is the potential to answer fundamental questions about the universe's origin and its future. We now have the tools to study the earliest moments of the universe, right after the Big Bang, and we're gaining new insights into the forces that shaped its evolution. Understanding how galaxies form, how stars are born, and how life might arise elsewhere in the universe are all pieces of the same puzzle. The answers to these questions could reveal our place in the cosmos and help us better understand our own origins. As we continue to explore the universe with JWST, one thing is certain: the journey of discovery is far from over. Every day, new data and findings are coming in, and with each discovery, we move closer to answering the biggest questions about existence, the nature of life, and the vastness of the universe. The James Webb Space Telescope is not just a scientific instrument. It's a symbol of humanity's insatiable curiosity, our desire to explore, and our determination to understand the universe we inhabit. The future is bright for space exploration, and with JWST at the forefront, we can only imagine the groundbreaking discoveries yet to come. Whether it's the hunt for life beyond Earth, unraveling the mysteries of distant galaxies, or gaining new insights into the very fabric of space and time, the James Webb Space Telescope will continue to be our most powerful tool for unlocking the secrets of the universe.